Meta has released the most powerful open-source large model in history, Llama 3.1, a 405B parameter model. In this video, I will summarize some key points about Llama 3.1 and the insights it brings us. First, let me summarize the features of Llama 3.1. The first and most important feature is that it is currently the largest and most efficient open-source model, with 405 billion parameters. This model can directly compete with GPT-4, which is currently the best closed-source large model. In terms of parameters, we know GPT-3 has over 170 billion parameters, and GPT-4 is in the trillion parameter range. What kind of insights does this model bring us? Very intuitively, it reignites competition between open-source and closed-source models. Before the release of the 405B model, it was generally believed that open-source models lagged behind closed-source ones. Moreover, new models derived from fine-tuning open-source models often performed worse than GPT-4. With the latest Llama model, could this paradigm be fundamentally changed? The performance of the Llama model can actually rival GPT-4, and with fine-tuning or adjustments, it is possible for it to outperform GPT-4 in certain fields. This is very good news for developers. Meta simultaneously released new 8B and 70B models, and all these models support a 128K context length. It is worth noting that the newly released 8B and 70B models are a level above other models of the same parameter size. Moreover, the 128K context length satisfies the vast majority of our needs. In addition to releasing the models, Meta also published a nearly 100-page technical report. This report covers detailed data-related information, such as data preparation, data processing, data collection, and how to use AI methods to generate large amounts of data. Many of the details mentioned about data can be applied to the fine-tuning process of models. I think this technical report is very valuable. Next, I will summarize the main reasons for the success of Llama 3.1, the 405B model, and the techniques or methods behind its performance that enable it to rival GPT-4. The first and most important reason is the model size, which is related to the scaling law. As we increase the size of the model, its overall performance improves accordingly. The second factor is the data size, which is the amount of data used to train the model. For the 405B model, a total of 15 trillion tokens were used. In contrast, only 1.8 trillion tokens were used in Llama 2. Apart from the size of the model and the data, there is also the work done on the data. If we look closely at the technical report, we find that much of it focuses on data, including how to collect data, how to process data, and how to construct data. This involves a lot of work in data cleaning, data construction, and data balancing, which have a significant impact on the final performance of the model. From the perspective of model structure, the new model has no fundamental differences from the old model. There are no significant innovations in terms of structure. The fifth factor is the improvement in directional capabilities. To train a large model with abilities like mathematical reasoning, logical reasoning, coding ability, and the ability to flexibly use various tools, a lot of work was done, as seen in the technical report. Some of these capability improvements focus on post-training, while others consider both pre-training and post-training. Regardless, the focus of these improvements is still on the data itself. What kind of data is collected, how it is processed, and how high-quality data is selected to train the corresponding capabilities. From these points, we can see that almost all the key work is on the data, making the model larger, and putting more effort into the data to produce higher quality results. This is a brief summary of the Llama 3.1 series large models. At the core of all this, it's still about the data.